This is my screencast for chapter 15, and I have chosen a problem from the book, which says as the center of a small spherical metal ball of radius r carrying a negative charge of negative q is located at a distance r from the center of a shorter thin wire of length l. If the radius of ball is 5 millimeter and q equals 1 into 10 to the power negative 9 coulomb, and the small r equals 10 centimeter and l equals 4 millimeter, calculate the force that ball exerts on the wire. This is a rough diagram, as you can see in figure 1, where this is a ball with radius r and negative q charge separated from the wire with a distance of r, and the length of the wire is l. As you can see, the ball makes a field that polarizes the wire as shown. You can see, since the ball has uniform negative charge, it causes the polarization of wire, and since negative charge attracts positive, this side contains the positive charge and this side contains the negative charge. We can also use the figure 2 to assume that this side has the positive charge and this side has the negative charge, and this E represents the electric field made by the ball on the wire. And since this wire is in equilibrium, the net electric field force inside the wire is 0. And we can use this idea that the net electric field is equilibrium to get an equation where E net equals E by ball, E on the positive end, E on the negative end. And since we know that electric field at net is 0, and we just put the equation that we had obtained from chapter 14 and 15, and after we calculate, put the values, we can get the value of q, which comes to be capital Q upon 8 L by R whole square. And you can add the numbers and get the value of q. Since we have been asked to calculate the force that the ball exerts on wire, and we know that from chapter 18 that the field made by the wire affects the ball can be obtained by the equation that is F equals Q, the charge of the ball, multiplied by electric field at wire. Since we can consider the wire as a dipole, we can use that equation from chapter 14, that is F on wire equals F on ball equals Q ball on E wire, and the E of wire can be given by the equation 1 by 4 pi epsilon naught 2 Q L upon R cube. This equation we derived from chapter 14, where we use dipole considering with charges positive and negatives at the end, and we simply substitute the value of q from the above. I just, instead of putting the numerical value, I just get the standard value, the q and l, so that I can have a better equation. And after substitution, I just kept the value of that is the 9 into 10 to the power 9 Newton per meter square per coulomb for the 1 upon 4 pi epsilon naught, and for the q put the value, and for the l and same thing. And doing so, I got a value of 1.4 into 10 to the power negative 11 Newton, and this is the force that the ball exerts on the wire. And the main concept of this equation is that the ball polarizes the wire, and also the net electric field inside the wire must be 0 in equilibrium.